Ready. Ready. Ready.
Hello, welcome to Enlightning. Today we're going to learn about Kyverno with our guest Chip Zoller. Chip, tell us about yourself, please.
Hello, everybody. Hi, Whitney. Glad to be here. Thanks for having me on. My name is Chip Zoller. I am a technical product manager at Nirmata, which is the company behind Kyverno. And I'm also a Kyverno maintainer. And I am excited to talk to you all and help you learn a little bit about Kyverno today.
I'm very excited to work with you. For one thing, I really like, this is a silly thing, but I make up a little GIF for every show, and I just really enjoyed the GIF you made. So I'm like, I like that guy. It's pretty easy to get my affection, I think, actually. But but also we got to work together just on Wednesday. I hosted a Cloud Native Live, and you happened to be my guest for that. So it's
Yes.
pretty serendipitous. I love how our paths are crossing. But one thing I just learned about you while we were chatting up top is that you used to be a professional educator. Tell me more about that.
Yeah, I actually spent a long time in college as a musician. So I have a doctorate in music performance. I played oboe and English horn, several orchestras, a lot of chamber music, toured with some orchestras around the country, and then taught at a couple of the universities at which I was pursuing a degree. So after 11 years in higher education, I
Uh-huh.
decided to do technology. And I still dabble in music, but not as seriously as I once did.
That's amazing. I played oboe in high school. Not oboe, but bassoon, another double reed instrument,
Uh,
which is and then I also toured in my brother's bands for a year. So we have that in common. But what I'm interested in to know is like, do you find that there's much crossover between being an educator or a musician and what you're doing now in tech?
I think there's a lot of similarities when it comes to the thought processes. You know, and
Uh-huh.
as a musician, you're constantly trying to listen to what's going on around you and react in a lot
Uh-huh.
of different ways. But also, when you're thinking and working with the technology itself, you're trying to solve problems with it that happens similarly inside of an organization when you're performing. So there's a lot of there are a lot of, and there's more than that, of course, when you start to get down into the nitty gritty and thinking about, almost architecturally, like how this stuff works, what the
Uh-huh.
implications are. Like there's a lot there, but yeah, there's quite a lot of similarities, but it's difficult to articulate those without kind of getting, pontificating over these. So
Yeah.
that's the high level.
I like the thought of like a system being an orchestra and all the different tools being different instruments and they're having to listen to each other and work together. And I guess the term orchestration is even really used, but I don't think I'd literally thought of a musical orchestra when hearing that word until right now.
Yeah, that's it's actually there was a really cool quote by Joe Beta, who obviously used to be at VMware, which is that Kubernetes is kind of like improvisational jazz, and it really kind of is, where something happens and then other things react based upon that event. So there's orchestration where everything is following kind of a predefined program, and that's typically what you think of in a typical orchestra. But in things like free and improvisational jazz, one player makes one move, you never know what that move is going to be, and then everybody else reacts in kind. So it's a very, very similar approach there.
What a fun mental model.
Yeah.
Fuel Snobble's here. Hi, Fuel Snobble. Fuel Snobble was here yesterday. So yesterday we actually did a show about OPA, about open policy agents. So we're doing a series of Enlightning shows about all the different policy tools that are currently available in the CNCF.
Cool.
So that'll be something we talk about later once we're behind the board. Is how does Kyverno compare to other policy tools in the CNCF?
Sure.
But don't answer yet.
No,
it's a cliffhanger. So what I do want to talk about is the folks who are watching live. If you want to go ahead and say hello and where you're from, that would be great. And also, I'm interested to know what's your policy strategy currently? Like, are you using a policy tool? Are you rolling your own somehow? Tell us about what you're doing policy-wise, and if there's anything in particular you're interested in learning today. Fuel Snubble says they're a bot. Fuel Snubble's a bot from Twitch who happens to know that we streamed about OPA yesterday. That's a great bot. And then Chip, what I want to hear from you while I move behind the light board, I'm interested in how you went from being touring in an orchestra to being a Kyverno person, getting a Kyverno maintainer and getting interested in policy and policy as code for Kubernetes.
Sure. Yeah. Well, strap in, because this is going to be the fun one. So it's all of the time that I've been involved in music, even back to my, I guess, middle or high school days, I was always interested in a lot of different things. I think that's one of the blessings of ADHD, is that you get bored very quickly. And so you have to look at multiple topics in order to keep your interest. And so, I was always, of course, very interested in music, but I was also very interested in technology as well. And so I always did both simultaneously, and sort of at the end of my 11-year tenure in higher education, I just made a decision that I'd rather kind of pursue technology at this point in time. And so I got a bunch of certifications and taught myself basically everything that needed to be done. Worked as a network engineer, as a storage engineer, virtualization engineer, consequently with VMware technologies. And maybe some of those who are watching today may have worked with me or spoken with me about this. But I was actually a consultant for quite a number of years, focusing specifically on VMware solutions. So software-defined data center with VMware, and also working quite a bit with cloud management platforms. Even in the early days when VMware acquired what was previously before vCloud Automation Center, and then of course became vRealize Automation, I spent a lot of time in cloud management platforms and automation, but really trying to make it work for customers out in the field. And a big part of that story is automation. And one of the themes that I picked up on that was incredibly important then, as it is today, actually maybe even more so today in the world of Kubernetes, where complexity is a sort of table stakes thing, which is it's really important to help people with technology, but to do things in an elegant and easy way. And one of the things that's very difficult is to do automation in that way. And as maybe you'll see today, Kyverno accomplishes that pretty well. And obviously trying to improve on that even further. But so that was a large part of what I did in the field, was trying to make automation and trying to make these complex behemoths like cloud management platforms and the software-defined data center and every other thing that has to get plugged into that easy to reason about, easy to consume, and easy to operate. And so that's what I did for a number of years for a lot of Fortune 500 companies. And then obviously, as time began to go on, yeah, Whitney.
What I like about that is you're not just trying to sell something. It feels more like you're trying to help an organization be better, as opposed to make money. And I just find a lot a lot of satisfaction.
My personal goal has always been, I don't know if, I hope I'm not stealing this from anyone or anything, but my personal motto has always been help the customer regardless. Like no matter what
Yeah.
your angle is, help people out, help people with what they need help with. And if it benefits you, then that's, awesome. But regardless, help them out. So that's what
Yeah.
I've always tried to do. And I've always tried to apply that approach is how can we help people with technology, but do it in a way that doesn't just benefit you, but what's the best thing for them. So you have to pull yourself out and say, all right, if we're switching roles, what would I want to do? How would I want to go about this? Do I really want, to operate this giant stack of stuff that's loosely put together and that has all of these just obtuse controls? Like, no, probably not. We all want easy things. So
Yeah.
that's been a lot of it.
We do have a comment from Alsif. Thank you so much for answering my question. They're using right now OPA Gatekeeper, which we learned about yesterday, and interested to learn more about Kyverno. So that's
Cool.
awesome. Thank you so much for your response.
Yeah, I hope that this is an enlightening session for you.
Okay. Can you hear me?
Yep, a little bit light.
My AirPods just came undone. So let me see if I can figure this out. Sorry about that. You can maybe, I don't know if you can hear me. All right, I'm back. Sorry about that. My StreamYard just decided to do everything through the computer instead of using my AirPods. But you can hear me?
Yep, you're good.
Cool, cool. All right, so to get started, what I would love to talk about is policy in general. Like why do we need it? Like what is it and why do we want it?
Yeah, it's always a great question and a good point to start with. So policy is really, it doesn't have to be, and it's really not just a tool for security people and a technology that's used to prevent bad people from doing bad things. Policy is really nothing more than a contract that you establish that sets expectations of other people and of actions that are performed on a given system. So policy can be, obviously, we think of it as part and parcel with security, but policy is really nothing more than a contract that's established between one or more people and a contract that's visible and has repercussions that are associated with it. And some of the things that policy can be used for, aside for security, are things like governance, like making sure that you have things like labels and annotations of a specific name and value. That's really not primarily a security function. That's a function of governance, and that's highly specific to each organization. So if you're working in energy, for example, maybe your labels involve some sort of, section of your energy system that only makes sense to you. Maybe you're in healthcare or you're in manufacturing and you have a similar set of concerns that maybe aren't shared with other types of organizations. Policy can be a governance capability in addition to a security capability, and we'll talk about all those, but policy can also be a helper for automation. Policy can apply things like automation based upon a definition that you install. And so you want some event to occur or some outcome to proceed from some sort of input action. Well, all of those things can be encapsulated in a policy, and that forms the contract between the inputs or the users or actions and the outcomes that are driven.
Excellent. I'm going to have you back up and repeat a little bit so I can get it captured well on the board. First, I want to say hello to Keith Lee. Hey, hey. So glad you're here, Keith.
Hey, Keith.
So what I heard was a policy is a contract that sets expectations for actions that can or cannot be performed in a system is the overall thing. And generally, policy is thought of alongside of security, but it's also good for governance. And you gave a good example, but I was a little bit tuned out trying to catch up with the other things. So will you tell me again, like a good example of where policy is good for governance? Actually, let's also do an example for security. Let's do examples all the way down.
So I would say
So,
security, governance,
uh-huh.
automation, and even things like finance or cost. So policy can
Okay.
be effective in all of these domains.
Awesome. Well, I think what I would like, and I would like your feedback, I would like to capture an example of how policy is used in each of those four
Of
cases.
course.
Cool. So what's an example of how policy is used for security?
So policy for security, this is typically what people start and end with when they think of policy, like, oh yeah, it's just going to be policy for pods. Like, for example,
Uh-huh.
ensuring that pods do not run in privileged mode. Like, this is a quintessential policy that just about every policy engine out there can express. And
Okay.
these are typically yes or no functions. We call them validations. That is,
Mm-hmm.
here is a thing. Let's compare it against a policy. Going back to the example, a pod shall not run as privileged. Here's a pod. Should it be allowed? Yes or no? That is an
Uh-huh.
example of a validation policy. That's a function of security. Do we allow the pod? Yes or no? It's a yes or no. There's nothing else. In the
Uh-huh.
case of governance, this might be something like, I have a label called team that needs to be on every, let's say, ingress. It could be any Kubernetes resource, but let's say it's an
Mm-hmm.
ingress. Again, it could be anything. But in my organization, I need to have a label called team or foo or pickles or what
Mm-hmm.
have you that needs to be on all of these resources, because that label has specific meaning to our organization and may even result in some sort of action performed down the line. So that's an example of governance. It's not a function of security. It's about governing how you need things governed. When it comes to automation, a policy example can be when a new namespace is created, or even if one is observed, I want you to
Mm-hmm.
create this new config map into this namespace. This is something that can also be defined as policy and is a function of automation. So when a
Mm-hmm.
new namespace gets created, which happens all the time as a function of things like multi-tenancy, you want something
Mm-hmm.
like a config map or a secret, for example, could be anything again, to be
Mm-hmm.
created in that namespace as a way to help you get up and running quicker, as a way to help bootstrap your cluster or your namespace and getting you out the door to production into your customers faster. So that's an example
Mm-hmm.
of automation. And then the
Mm-hmm.
fourth one here is cost. One of the last domains is cost. This is incredibly important in things like cloud environments, like EKS, AKS, what have you, where the actions that you take can result in spawning infrastructure that has a cost associated with it. So one of the things here,
Mm-hmm.
for example, there should not be any load balancers or services of type load balancer in a given namespace. So a policy can be written to ensure that a service of type load balancer that normally results in creation of a cloud provider's load balancer, again, in these cases where you're running a cluster in a platform as a service, it should
Mm-hmm.
not be created. So this is a function of cost because you want to control that so that you don't incur additional or unexpected costs.
Is it so this all seems very important. Is it a given that like policy every organization has a policy engine probably immediately as soon as they're adopting Kubernetes, or is it possible to be running Kubernetes and not yet learn about policy?
Unfortunately, many people are still going to production without running policy of some sort. However, it is getting less and less common. So
Uh-huh.
fortunately, policy with the multitude of tools that are available is becoming more common, but it is still seen where a lot of folks are operating a Kubernetes environment without any sort of policy. And in some
Fascinating.
cases, policy may not be strictly necessary in every single situation. Like, for example, if you're spinning up a kind or Minikube cluster, or even a small cloud cluster that may be used by very specific few people, very narrow concerns, maybe you don't need full-blown policy, but in most cases you should have some at least basic policy that covers the first one that you covered there, Whitney, security. You should at least have some
Mm-hmm.
policy that covers some security, because Kubernetes by default, even though it has some choices available, they aren't enabled. So you have to do something to at least cover for that base.
So then if it's relatively common for organizations to go to production without policy. Are they doing something, or are they just being pretty risky? Like, are there like hand-rolled scripts or something that they're running, or?
Well, very often what we see is people go to either pre-production or maybe sometimes even production without having policy, and then they wait for
Mm-hmm.
bad things to occur. And then
Okay.
only at that point in time do they realize, oh man, we need to do something about this. Well, how do we solve that problem? Oh, yeah, well, we
Uh-huh.
heard policy is probably good. Again, that's
Okay.
becoming less common, but
Uh-huh.
sometimes it does
That's
happen. And
that's very human.
unfortunately,
Yeah.
waiting for bad things to happen, it's kind of too late because you don't know what's going to happen if you don't have policy in place.
Yeah. Fascinating. This is great context. Thank you so much. Um, so this is what I needed for the context to get started for what you want to teach about Kyverno. So I'm going to give it to you, although I will say that I would prefer to have a what is Kyverno definition sooner rather than later.
Yep.
But if you want to give, and I want to say hi real quick to Malachi. This is a new viewer. Thank you so much for joining. Everything's flipped, so I'm not writing backwards. This is all facing me, and I'm impressive in some ways, but writing backwards is not one of them. All right, bring it on, Chip. Let's do this.
Yeah, so I'm glad you mentioned that, Whitney, because that's exactly what I intend to cover. Like, what is Kyverno? For those who may have never heard about this tool, Kyverno, simply put, is a policy engine built specifically for Kubernetes. It is a purpose-built policy engine that uses the same paradigms and idioms and knowledge and skills and even other tools that you're currently using to work with Kubernetes and other ecosystem tools to give you policy without having to learn or to use a programming language, whether specific or generic. That is, in a very quick summary, what Kyverno is.
So one thing you kind of touched on that maybe I want to dig into, it's your story, but I have questions about, is what are the benefits of the fact that it's specifically for Kubernetes and it's not trying to define policy for other tools? So you said no code, so being able to work in YAML, and then probably it plugs into the whole Kubernetes ecosystem. So then you're doing policy around any tool that works on Kubernetes.
Yep.
Maybe. And then does a Kubernetes control loop maybe come into play for a benefit?
Yeah, that's part of all of those things are part of Kyverno, but it goes even more than that. When you think about why is it important that it's purpose built and not specific? Well, a couple things. First of all,
Yeah.
if you look at how policy and those in the real world who use policy, most of those people are people who either do not have time or don't have the skill set to be able to go and learn an esoteric language or even a generic language like Golang or something. Whether they can do that or not, they don't have the skill set or they don't have the time to invest in doing that for the sole purpose of expressing policy. So it's extremely important that you be able to recycle the existing skills that you have because let's face it, we use Kubernetes every day to do all sorts of things. We request pods with them. We request load balancers. We request certificates. In the case of some of the VMware Tanzu products, we even request entire new clusters just by writing YAML. Why is it that we can't recycle that same knowledge to just give us policy? That's what we think that you should be able to do. And so we want to bring down the barrier to getting policy in a way that meets you where you are using the tools that you already have. And so on that second point, using the tools that you already have is extremely important. You're using things like Helm, Customize, maybe you're using tools from Carvel like YTT or other things like that to be able to manipulate your YAML files. Well, with Kyverno policies, because they're just written as standard YAML, you can use all of those same tools to manipulate policies just like you would, let's say, Cert Manager or a deployment or something like that. So those are a couple of important things. And also the last thing.
Will you repeat to me what Kubernetes tools you said? Helm?
Yeah, Helm, Git, Customize. Those are very popularly used tools that you can use to manipulate Kyverno policies.
Okay.
And then I guess the last important point is when you talk about policy, again, in the real world, because we're very much attuned to how folks are using this, it's really important that other people in an organization be on the same page as you. It might be awesome that you can write and read this esoteric DSL or something else, but there are other stakeholders in a company that need to understand what policy does as well. And if it's written as standard Kubernetes, the likelihood that other people are going to be able to read and understand that is far higher than having to train them on a programming language just to be able to understand and be on the same page as you and speak the same language.
Is DSL the one that Terraform uses?
DSL is just in general a domain-specific language. So some tools out there, some tools out there have their own language in order to implement policy. Kyverno doesn't, and we think that that's extremely important for those reasons that I mentioned.
Excellent. So I'm going to put like readability of policy, or what's a good way to capture that point in on the board?
It's really universal reasonability is kind of how I think about it. Anybody should be able to reason about a policy without having to attend or go through a 2 to 3 month masterclass on, you know, specific technology that is isolated to that type of technology, that policy engine.
I like that. I'm glad I asked. That was better than what I was coming up with on my own. Cool.
And so just let me address Asif's question. So they are asking, do you mean no more Rego? And yes, so Kyverno does not use Rego, which I know you, since you previously had a session on Open Policy Agent, which is a great tool, by the way, but Kyverno doesn't use Rego, which is an esoteric DSL. Kyverno doesn't use Rego to express any of its policy. You can do all of the same things, and actually, as I hope you'll see, even more, without having to write any Rego whatsoever.
Excellent. Excellent. And so where would you like to take this next?
I think it may be important to just point out, since we kind of started with what is Kyverno, and before that, why policy is important. So let's maybe talk about, we talked about some examples of what policy is good for, but maybe we could also talk about the main capabilities of Kyverno, and then we can explore each one of those with some specific options so that you understand those main capabilities, what you can do with it that's valuable or helpful to you.
Cool. So main
if you want to rewrite these in any way, we can certainly blow it up and rewrite it.
Sure, we'll figure it out. It's half the fun and not know exactly how it's going to go. Kyverno.
And this is my first Lightboard session, so I'm seeing in real time the results of my education. So I may have to backtrack and say, you know what, I didn't express that very well. Let's do that again.
I love that. Good. Feel free to do that.
All right, so the main capabilities of Kyverno. Kyverno has a whole lot of capabilities, and some of them are pretty cool. So let's start with the first one and most common one.
Okay, I'm listening.
The first one is validation. We call, and these are expressed through rules, which we can get into, but the first capability, which is the one that's most common to everybody when you talk about policy, is validation. This is that yes or no response that we mentioned in the security aspect. Here's a pod that should not run as privileged mode. Do we allow it, yes or no? That's a very simple function, and Kyverno does very well, but that's the first capability that Kyverno has. It's a yes or no response. That's validation. The second
a yes or no response, always to the question, is it allowed?
Yep.
Okay.
So validation is just about the Kubernetes API server handing you something based on a request that you've made, and it asks, do I want to let this proceed? And it's looking for a yes or no. That's all you get.
Cool. All right.
All right, the second capability is called mutation. Mutation is the ability to change a resource in some way. And again, all of these things are based on policy, which we'll get into. But the second ability is, here is a resource. Do you want to change it? If so, send back to me the changes that you want to make. This is mutation.
Should the resource be changed? And then if so, how?
Yes.
And when we say a resource, what we mean is a Kubernetes object. So a
Right.
deployment or a pod, or I mean, it could be a custom object, presumably.
Any Kubernetes resource, any sort of API resource, sometimes called an API object. So good point. When we talk about a resource, we were talking about any API object that's in Kubernetes, whether it's a built-in resource like a pod, a deployment, a service, or a custom resource like a cert manager certificate, or one of the cluster API resources. Those are custom resources. So all of these capabilities apply to any Kubernetes resource. It does not matter what type it is.
I think that's important to capture. So resource validation, I think that's, and resource mutation. Cool.
So I guess Whitney, it would be maybe be good to kind of step back and to cover one point of how, I guess more generally, and we didn't actually use this terminology yet, an admission controller works in Kubernetes, because it may help people understand some of the nuances that we could get into later here. So maybe just let me step back and cover that really quick. So an admission controller is a component, an optional component in Kubernetes, which, as the name implies, is software that participates in the admission of these resources that's in a cluster. And an admission controller is a piece of code that runs typically inside of a cluster, usually in the form of a pod, and it forms a contract with the API server in order to get specific resources sent to it. And this is what's called a webhook. A webhook is a Kubernetes resource, just like any other resource. That's basically a contract or a order form that asks or instructs the API server several pieces of information, primarily what it wants to know about and at what address or location they should be sent. So, for example, let's frame this in the first capability. Let's say that you wanted to do a validation of a pod, since this is probably the most common resource.
Okay, you're getting ahead of me, please. An admission controller is software that has a contract with the Kube API in the form of a webhook.
Yep.
And then what's the end of that, please?
And that would be
to what end?
That forms a contract in order to form a bridge between the API server and the admission controller. So I guess to finish the sentence, an admission controller is software that has a contract with the Kubernetes API server, which is capable of validation, mutation, and other actions in the cluster.
Okay. Thank you.
Something like that. Yeah, that sounds good.
Okay.
Yeah. So to I guess expound on that, or to finish the idea of how that actually works, imagine that you wanted to validate a pod. Again, you wanted to, we'll use the same example that we started with, assuring that a pod does not run in privileged mode. You would create a webhook, and the webhook tells the API server, hey, I would like to know about the creation of pods, and I would like you to send those to me at this address. And when a new pod gets created, the API server will see that webhook, and it will send any new pod, or again, whatever the resource is, to the address that's defined in there, which the address is the admission controller. And so this is the bridge that an admission controller like Kyverno is able to form in order to get resources funneled down to it. And so this is important because remember, the name is admission controller. When a resource is being admitted, it does not yet technically exist. It is a proposal for a resource.
Mm-hmm.
So if I, as a user, or you, Whitney, as a user, try to create a resource, and you have an admission controller which is registered to listen to those resources, the first
Mm-hmm.
thing that's going to happen after you're authenticated and authorized to do that thing is it's going to be sent to an admission controller. And in the case of validation, it's going to ask for a yes or no response. Whitney would like to create a service. You have a policy that matches a service. Do we allow this, yes or no? And that's how the end-to-end flow works in the admission process. If the answer is no, you do not get to create that resource. If the answer is yes, the resource is successfully created and it becomes an existing service.
So to validate a pod, you first, as a user, you create an admission controller webhook. So then upon the pod creation, the Kubernetes API server sees that webhook and will send the pod creation request to the admission controller?
Yep, and all of this happens with Kyverno automatically. So you don't have to create or manage a webhook in any way. All you do is manage a policy, and you write a policy, and the policy is extremely easy to write. And in order to state your intention, which is, I would like to validate a pod, please, all you have to do is create a policy. Kyverno will take care of everything else of informing the API server in the form of a webhook to receive the requests, to process the requests, and to deliver the response.
So I want to capture that for sure. So it sends the pod creation request to the admission controller, and then the admission controller responds with yes or no.
In the case of a validation, yes. In the case of a
Yeah.
mutation, it's a little bit different.
Yeah. Okay. But we're talking, this example is a validation,
Yep.
but yes.
We'll just start simple here.
Yeah. Okay. And then I want to capture that all of this happens automatically.
So this is just an understanding of what happens in the plumbing so that you understand more generally what an admission controller does. And we talked about why in the form of policy would an admission controller be necessary, because many of these things are so specialized that you need some sort of specialized logic to be able to deliver the outcomes that you need. And so that's where an admission controller comes in. It's extensibility for Kubernetes.
So when we say all of this happens automatically, what doesn't happen automatically is the creating the admission controller webhook. That's what we're using Kyverno to do, correct?
We are using, Kyverno will handle all of that stuff automatically. All that you're responsible for doing, obviously installing Kyverno, but then installing a policy, and that's it. And once you install the policy is the contract. We talked about policy being contracts. The policy is the contract of what you want to happen on what type of resource and what type of behavior that you want, and everything else Kyverno handles. So your sphere of concern is to only determine what it is that you want and to capture that in the form of a policy. And once that's created, all you now do is wait for those things to occur, and then the desired behavior goes into effect.
All right. So all of this happens automatically. You just install policy and Kyverno does the rest. And I think that's, I think it didn't fall off the board. It's on there. Yeah, great. Cool. Okay, so I like that we took a step back and then described that. And then by resource, I'm going to write can be Kate's or CRD custom, or I guess custom resource.
Yep.
Okay.
I'm loving your various colors. They make it very, very easy to follow.
Excellent. Thanks for appreciating my very specific kind of art. Great. So the main capabilities of Kyverno, first we have resource validation and we have resource mutation. So should the resource be changed? And if so, how?
Yep.
So I've heard an example of this is, say, number of replicas. Like maybe you're not allowed to have more than 8 replicas of it running in your Kubernetes deployments. And if so, you could, instead of rejecting it, saying no, maybe it just knocks it down to 8, and that would be a mutating.
That would be a perfect example of that.
One thing I have heard though, and I'd like to hear your opinion on this, is that resource mutation is a bit of a no-no in terms of transparency in what's happening in your system, that you would want to define everything through infrastructure as code for GitOps. And when you have mutating webhooks, then you're losing some of that transparency of what's happening in your system.
Yeah, that's a great point. And that's absolutely true in a lot of regards, where you want Git, for example, because that's typically what we see most often, to be the authoritative source on the state of your resources. And so you should absolutely still try and do that. But a couple things. In the real world, again, not just you might be out there in the forefront by doing full-on GitOps. Not everybody is doing that. So got to take a step back and realize that where you are might be more advanced than where others are. So Kubernetes is growing rapidly, and people that have never done Kubernetes before, they have to get started someplace. And typically you're not going to go full speed running into GitOps when you don't know what a custom resource is, for example. So not everybody is living the GitOps dream. That's the first thing. The second thing is that depending on the changes that you want to make, it's not possible for you to define all of this stuff in Git. Like, so for example, it's very common you want to define what your deployment looks like. It should have these resources or requests. It should run as this image. That's all great. But some things are only determined at runtime. And for those things, you can't know those in advance. And those can be all sorts of things like being able to write who created or what created the resource so that you have an audit trail. You don't know that in advance. You have to only ascertain that at runtime. And so a mutation can be a way not to replace GitOps, but to augment GitOps and to add things that you wouldn't normally be able to do.
Good to add info that can only be known at runtime. I'm leaving this little space for my face later.
I'm
not very big. Yeah, great.
So
okay, so
okay.
And then what's
okay, so we got to keep trucking because there's a lot more here.
Okay, let's do it.
All right, so third one, resource generation. You could just say generation, or if you want to continue with resource, you could do that. But generation. This is the ability for Kyverno to create all new Kubernetes resources, as in that they literally didn't exist until some event occurs in your cluster. And an example of this might be, and I think I used this on the automation use case side, is if a new namespace is created, clone a secret from this namespace into the new one. And so this can be an enabler for things like multi-tenancy, or some people call it namespace as a service. There are many different labels, but this is a capability that Kyverno has that's enabled with a generate rule, which again, this is all policy as code, all as YAML, no programming language required. It does this to specify that you want to create or generate a new resource based upon some sort of event that happens in the cluster.
And that enables multi-cluster?
Multi-tenancy and or namespace as a service. It's called different things. This is one of the primary use cases. There are, of course, other things that you can do with it, but this is a very popular example and commonly used in Kyverno for doing things like namespace bootstrapping. You might hear this as bootstrapping, or in some cases it's full-on cluster bootstrapping or cluster registration. But that's the generation angle.
And this is a good example of the automation aspect,
right?
Yeah.
Yep.
Yeah. Cool.
This is why Kyverno can really, for those folks who are DevOps or SREs or platform engineers or whatever your title might be, this is what gives you the ability to help with your cluster operations and not just provide security and governance, which, those are obviously two very important things for a policy engine. But that's one of the reasons that we wanted to call out at the beginning, that policy can be so much more with Kyverno.
Yeah.
And one of those things that encompasses the more is automation. So policy as automation, and that's what the generation capability and can be combined with any of these can deliver. So that's the third one. And so now we got to go on to the fourth one.
Okay.
So fourth one, software supply chain.
Interesting. You just said some very popular buzzwords.
Yeah, I did, but I'm going to explain that they're not actually just buzzwords and what they actually mean here. So in software supply chain, this is enabled by a rule type called verify images. And you could just consider it verify images, or you can write software supply chain. What we mean in this capability of Kyverno is that we want to ensure the software supply chain of your container images. And Kyverno does that in two very important ways. It, number one, checks the signatures on your container images. And the second thing is it validates if they exist, and if you obviously have a policy, attestations. And we can dive into what each of those things mean more in depth. But these are the two angles that Kyverno can deliver with its software supply chain capability: verify image signatures, verify image attestations.
I did an episode on SigStore a while back, and we talked about attestations and signatures and stuff. So I think maybe instead of digging it into it here, if someone's curious about that,
you just refer back to that one.
Yeah. And what's good about referring back to old Enlightning is you can just find where it is on the board, and then it's really easy to fast forward to the point where you want to hear, because once you see me actually writing it, then that's when we're talking about it,
Yeah, and it's perfect to refer to the SigStore one, because that's actually one of the two technologies that Kyverno supports internally. So that dovetails perfectly, because Kyverno supports SigStore technology in its software supply chain ability. So you don't necessarily have to install something separate. If you're using SigStore today for image signatures or attestations, Kyverno can validate all of those things for you out of the box without having to bolt anything else on. And it also supports Notary, as you've put down there, so that's good. You know that from the other day. So.
Yeah. When we did our episode on Cloud Native Live, we talked about, you all did a great demo around that. So when we say the buzzword software supply chain, we mean that we want to understand the origin of all the software we're consuming as part of the software that we're making and delivering.
Ultimately, it means something more than that. It means that we want to ensure that we're knowing that the software that we're deploying, not just where it came from, but that everything is as we expect and everything is okay, which ultimately we hope to result in higher and better security. One of those things can be knowing where it came from, and that's called provenance. And that can be done with an attestation. But there are other aspects as well. The broader goal is to ensure that we're running only what we expect and are okay in running.
Yes. I love that. Do we have some more main capabilities?
We have one more capability, and you're out of space right there. So unless you switch over to your ballpoint pen, it's going to be really tricky to stick that in. We have one more capability to cover here.
It doesn't show up. We got this. We're professionals.
All right, so the fifth thing here.
Oh, I said I'm a professional, and I wrote the number 6.
Just kidding.
All right, the fifth thing.
The fifth thing here is cleanup. Kyverno can clean up resources in your cluster. So you could think of this as the opposite of generation. If it has the ability to generate resources, it also has the ability to clean them up. And this could be, again, as you've wrote there, Whitney, resource cleanup. So any resource, you can clean up any resource based on any definition that you want. So for example, let's say that you wanted to remove old pods. You could use a Kyverno policy to locate pods that are older than a specific time period or older than a specific interval, whatever, what have you. And Kyverno can remove those automatically based on a schedule that you define. And again, all of these things are done with policy of slightly different types, but they're all expressed similarly using YAML and no programming language. So resource cleanup is the fifth main capability of Kyverno.
So I actually have a question because of the word resource is used in all of them except for number 4, software supply chain meant for images only.
Yeah, so it's a good point. In Kubernetes, the atomic resource of scheduling is the pod. So only pods run containers, and only containers reference images. So therefore, software supply chain security is really about securing container images that are in pods. Now, these could be pods that are created as part of your standard deployment, daemon set, stateful set, job, cron job, what have you. But also there are many custom resources out there that create pods indirectly, things like Tecton tasks, for example, and other, no doubt, I'm sure there are plenty of other things that are out there as well. Even some custom resources that have pods as a component of them. They're more like composite resources. Software supply chain security is about securing any container image that comes into Kubernetes via a pod.
Excellent. Thank you for verifying, for clarifying. Excellent. All right. So those are our 5 main capabilities of Kyverno.
Yep.
Yeah.
And I didn't want to go into, there's technically a 6th, but it's kind of an offshoot of something else, so I won't go into that. But these are the 5 main rule types that Kyverno has.
Well, now you've piqued my curiosity, Chip. You're like, there's technically a 6, but I'm not going to tell you about it.
Well, it's I don't know.
Now we got to know.
I can so you can
I don't have to
decide
write
whether
it
you want
down.
to write this or not. So the quasi 6th capability is what we call a policy exception. And the reason why I don't call this a main capability is because a policy exception is, as the name implies, it's an exception for any type of policy. It doesn't matter what either of these 5 are, what type it is, but a policy exception is a separate capability that Kyverno has that allows you to decouple or separate what types of resources should be exempted from policy. And there are many ways that you could exempt a resource from applying to a policy, but policy exceptions are a specific custom resource in Kyverno that allow you to separate this into its own type. And the reason why this is important is that you want to decouple those things.
Did you say policy exemption or policy exception?
Policy exceptions.
Exceptions.
Policy exceptions. And policy exceptions can allow you to exempt any resource from any policy based on a separate definition.
That's Fuel Snobble yesterday during the gatekeeper, or just open policy agent episode, did ask a question about, like, what if there's a fire and things are burning down and we need to be able to get in there and we have policies in place so that we can't, like, what happens then?
Yeah, so there are many ways that are around that when it comes to exempting resources, but a policy exception could be one way to do the so-called break glass routine, where you need to be able to get around a certain policy very quickly. A policy exception is a great and also popular way of doing this. But the reason that I call it out is because it's not just those who have the ability to write policy, anyone can write a policy exception and send that for approval. Well, the approval would be on you, but anyone can apply for a policy exception and say, hey, I need to break glass right now. Let me create a policy exception to allow this exemption. Now, again, there are many ways that you can go about exemption. We probably won't dive into all those things, but you can specify them in the policy itself. But a policy exception, I only call this out because it is a separate way of doing this, which can be just another tool in your toolbox.
Excellent. Thanks. I'm glad we covered that. One thing that you said, that I think this was pre-show when we were talking, but you may have said it on air, is that Kyverno is very popular and getting to be, I think you used the word de facto tool. Will you talk about that a little bit?
Yeah, sure. Obviously, keep in mind, my bias, and I am a Kyverno maintainer, and I work very closely with the Kubernetes community and obviously the Kyverno community. But I've been to a couple KubeCons, and I spoke fairly extensively at the last one. And one of the things that we continue to hear is the popularity of Kyverno is it's kind of exploding. It's the most popular by stars. I realize that's like a terrible vanity metric, but it does at least give you a kind of an idea of how people think about it. And it has kind of become the de facto standard for applying policy in Kubernetes. And the reason why is because, again, going back to what kind of our earlier talk, it meets you where you are. You get to reuse your existing skills and knowledge. It doesn't ask that you learn a specialized language in order to implement policy. That means that you're going to be quick and easy to get up and running with it. And that's resonated with thousands and thousands of people. And we just see it everywhere now. So it's really kind of become the de facto standard for if you need policy for Kubernetes, you start with Kyverno, and then if that doesn't work for you or you don't like it or whatever the case may be, then maybe go from there. But that's what we see more and more commonly, is that this has kind of become the people's policy engine of choice.
Awesome. Cool. What would you like to teach about Kyverno next?
Well, so we covered the main capabilities. I'm curious if anybody is out there, would like to hear from them to see if any one of these, we can start and go into depth on any one of these, but would anybody out there like to kind of double click, as it were, on any of these? So feel free to put your comment in there and we can take a look at it. But maybe since we've talked about what the main capabilities are, we can talk about how you can express a policy, because there are a couple ways that you can do this. So any of these policies, so actually let's back up. Each of these main capabilities of Kyverno are what we call a rule type. These are a rule type. A policy is a collection of rules. A policy can have one or multiple rules where the rule types inside of the policies can be of different types. They typically aren't, but they can be, and there are use cases for that. So a policy is a collection of rules. And there are a couple ways that you can express policy in Kyverno. One of the ways is you can write a cluster policy, and a cluster policy, as the name implies, applies to your entire cluster. So just as simple as that. And we'll get into how you can narrow the scope of this, but there are two ways of expressing a policy. One is with a cluster policy, and the other one is with a policy. And those are literally the names of the custom resources: cluster policy and policy. So cluster policy applies to your entire cluster. And again, a policy is a collection of different rule types. And then a policy is a namespaced expression. So a namespace policy only applies to the confines of the namespace where it is defined.
So cluster policy and policy are basically the same, except that one is cluster scoped and one is namespace scoped.
Correct. So
Okay.
you can think of it as no matter what your starting point is, you can narrow the scope, and we'll talk about how you narrow the scope right now. You can narrow the scope of each one, but you may not increase the scope of each one. So a cluster policy is maximally scoped at the cluster. A namespace policy or just policy is maximally scoped at the namespace.
We have a question.
Yep, I'm gonna. So
Okay,
I
great.
see a question here from Alsaf. Not sure. I apologize for the pronunciation. Gatekeeper provides an extensive library of ready-to-use policies. Do we have a similar Kyverno repository? Yes, in fact, we do. And not just does Kyverno have a repository of policies, it's actually the largest repository of policies of any policy engine. As of the 1.10 release, which we released earlier this week, I think we're up to 283 policies. And this is far more than any of the other policy engines that are out there. And many of these come from community contributions. And by the way, if you like to use Artifact Hub to see all things Artifact, all Artifact things, Kyverno policies are actually the fourth largest or most populous Artifact type on Artifact Hub. So yes, absolutely. We have a ton of ready-to-use policies. And by the way, policies not just for your standard Kubernetes resources, but for a lot of these third-party tools that we talked about out there, like Argo CD, Flux, Istio, Linkerd, you name it, there's a policy out there. Valero's got a lot of policies for Valero, which is a popular tool that is close to many of your hearts, and more. So if you don't see a policy out there that you can readily pick up and use, or at least customize, let us know. We would love to know what tool you're trying to write policy for, and we love community. If you have a policy that you want to contribute so that other people can use it as well, we happily accept those and pull requests so that the broader community gets to benefit from it.
I would like to capture that on the board, but I don't know if we have more to say about the custom resources.
Probably not for just the high level, but we could talk about the next thing is how you define what scope that you want. Like, what thing do you want to apply policy to? Did you want to talk about that?
I trust your judgments.
Okay.
I'm an empty vessel.
Okay.
I'm the water.
So we'll
take the shape of the vessel.
We'll then talk about how you express the desire of to what thing you want to apply policy. We probably won't be able to go with the remaining board space of how to actually write these policies, and it's pretty simple to do, but nevertheless, we'll at least talk about how you can scope a policy. So in Kyverno policies, all of the Kyverno rule types, and therefore policy types, have what's called a match block. So we need to, with this block, we need to express what thing should be applicable to policy. Not what the policy does, but what thing are we interested in expressing policy?
Every what has a match type? A rule has a match type?
Every rule, regardless of its type, has a match clause or block or thing.
Okay.
And the match is going to, as you would guess, define what matches the policy or rule and what logic should apply that happens later on. The match block is very flexible and also very easy to use in that inside of a match block, you can express things like your resource kind. Like, I want this policy to apply only to services and not to anything else. So it defines several things, one of which is the resource kind. That would be probably the most important thing, is the resource kind. And there are a lot of different optional things. You probably don't want to write them all down, but I'll
Okay.
give you some examples and you can select which, if any, you write down. Some other things that you can define in a match block are things like the namespace name that you want to match on, the label that you want to match on, the annotation that you want to match on, the namespace label. If this is a namespaced resource, you can select based on the namespace label in which it occurs. You can go further. You can select the username. You can select the group. You can select the operation, as in, is this a creation, an update, a delete? You can even go even further. Kyverno has the ability to select things that normally aren't part of what the Kubernetes API server sends to admission controllers. Things like your roles or cluster roles. Kyverno can calculate those on the fly and allow you to match based on what role or cluster role does this entity have when they're submitting a resource.
So the match this defines the resource kinds that the policy will be applied to, but then also the logic of there's also logic in there,
Not the
you said,
logic
right?
itself. The match is only intended to match the resources.
Sorry,
So, for
I just
example,
dipped away on you.
no
My
problem. I'll give you an example of the governance while you're dipped down there. So we talked about governance, and one of the examples that we used was label every ingress with a certain label. Well, let's say that we removed the ingress word from that. Or actually, no, we actually need to keep that. You only want that label to apply to ingresses and not, for example, services. So you need to be specific and only require that the label exist on ingresses. That's where the match block comes into play. You say in your match block, I only want to match on ingresses.
So the match defines the resource kind to match on.
Right.
Okay.
And optionally, those other things that you pointed out.
Okay. Cool. My laptop power, I thought it was plugged into the wall, but it was anyway, I had it plugged into my machine, but the wall part wasn't plugged into the wall. So my computer was like, "Hey, I'm about to die," and so therefore that's why I dropped to go plug in the
classic error.
Yeah. All right.
Okay, so probably the second thing then, since we have a match, and this goes back to what I was saying with policy exceptions, we now need to be able to exclude resources because your match, think of it as like the widest net that you want to catch. But there are things that you don't want to be in that net and you need to exclude them. So we have an exclude block as well. So we have a match block, and now optionally you can use an exclude block as well. And an exclude block is basically the same thing. It has all of the expressive capabilities as the match block, but allows you to put things in there to further refine the resources that should be applied to the policy or the rule that you're writing.
The exclude block
defines
enables you
what you don't want to match on if it's already caught by a match.
Okay.
So for an exclude block to apply, it has to have already been caught by the match.
I like I'm learning your lingo, like catching. Yeah.
Yeah, I'll do much better job on Enlightning 2.0 when we do a recap of this. I'll get my notes and be more clear next time. But.
Oh, I think you've been amazing.
So yeah, the match block is what do you want to initially catch, and the exclude block is what holes do you want to poke through to let the smaller fish drop out of that.
I like that. It seems fun to write policy. It seems like a brain teaser.
I actually think so. I thought that maybe I'm just unusually nerdy and geeky, but that's actually one of the reasons why I became a Kyverno maintainer. So I guess to to give your arm a break for a second. I mean, people ask me all the time, how did you get involved in this? Well, one of the reasons was that I was, as many are, in the case where I needed to apply policy for customers that were actually VMware customers that were running and needing to deploy Kubernetes in production. And so I needed to go and learn policy to be able to help these folks out. And the thing that I ran across were some tools that required me to learn a new language to do that. And I remember doing this. I remember it was vividly. I went, oh, not this again. I can't do this. I can't learn one more language to apply to just one specific tool. Like I have a job that demands that I do productive things. I can't take 2 months to learn a new language to only write policy. Like it's when you're working with Kubernetes, it's just not reasonable to ask people to go learn yet another language to only use your tool. It's just not reasonable.
Yeah,
so
it's true.
I went looking around and I found Kyverno and I thought, okay, policy is YAML. I know how to do this already. I know how to write this. I've been writing, deployments and pods and all those types of things for a while. Yeah, I think I can do this. And so I was actually up and running, implementing policy in like 2 minutes. And,
nice.
And these weren't policies that I downloaded and installed. These were like use cases that I had written down on a notepad. And I'm like, okay, I need to find out, like, how do we ensure that the label, Cheeto Monster is on all pods? Like, okay, well, there's not going to be a Cheeto Monster sample. So how do I do Cheeto Monster for, Acme Corporation? All right. In 2 minutes, I was doing that. In 2 minutes, I was doing that and other things as well. And this is one of the main successes that we hear all the time, that people come to Kyverno like, hey, I didn't realize that I could get policy in 90 seconds, 60 seconds. Like, I can do this. And then back to your point, Whitney, like, it almost seems fun. Like, yeah, it is kind of fun because it's simple to write and reason about. And when it's simple to do that, you kind of want to go and find these use cases to solve. So yeah, it can be really kind of fun. And so that's kind of what drove me here to work on the Kyverno project and, to try and make it even easier to do, and hopefully sometimes fun to do some of these policies, is that they're all pretty easy to write and reason about. So have a good time doing it.
Yeah. They remind me of like brain teaser books I had as a kid.
Yeah, sometimes thinking of, especially some of the more complex policies, they can be very much brain teasers.
Cool. And then it speaks to like the complexity of the policy, but then also the flexibility of the tool to be able to help you solve your brain teasers.
Yeah, and actually, I've written. I've kind of brainstormed a KubeCon session that I think I want to submit. I think I want to submit a session where I just talk about my experiences in writing policy, just from the trenches, like what are people doing and why are they doing it?
Yeah.
And I've probably written thousands of policies at this point. Like a lot of the policies that are in the policy library, I've written to help other users, or I've written for other needs, or, a lot of them are contributions. But after having done all of that, like some of these brain teasers, it's really kind of amazing actually to see not only the fun that you can have with it, but also the fact that at this point in time on this version, there is literally no use case that I can think of that you cannot write with Kyverno. There's not one real world use case that I have written down that I have seen that it cannot express. And that's pretty cool to see.
We talked at the beginning kind of about putting out like people who are not using policy engines and then just discover Kyverno or other policy engines because things are breaking. Do you have, like, speaking of from the trenches, do you have good stories about stuff that's like it's breaking now and we need a policy to come in and fix it? Is that a thing?
Yeah, I mean, this happens unfortunately on a weekly basis. Like, for example, and I guess it's important to point out, like, policy is not just to prevent bad people from doing bad things. Policy can also be used to help us prevent us from doing things that we might have done accidentally. So
Yeah.
one of the cases might be I accidentally created a load balancer that was of size super mega make milkshake large, and it cost my company, $80,000.
Uh-huh.
Or I accidentally created a deployment that I wanted 10 replicas, but somehow, like, my cat walked across the keyboard and I got 10,000 replicas. So those are things like guardrails for us, because
Yeah.
sometimes things happen and we make errors. So those are a couple of, now the cat example is a little bit extreme, but the load balancer one I have seen multiple times. But
Yeah.
unfortunately, the one that I continue to hear that's hard to hear is, hey, we're looking for policy because we just got hacked, or somebody ran a crypto miner in our cluster and it cost us, an additional 30,000 in our EKS bill.
Ooh.
And we can't ever let this happen again. Like, we've had
Yeah.
major, so bad things happen. And unfortunately, bad things are often the teacher that drives us into the arms of technology to solve problems.
Yeah.
Where if you had policy to begin with, a lot of those bad things wouldn't happen. So, one of the basic things is, like, for example, not letting users pull images from Docker Hub. I mean, it could be any image registry, but as with any tool,
Or
you open it up.
another way to express a similar policy is like, you're only allowed to pull images from this registry.
Right. That could be, that's an inversion of that logic. So you could say that as well. But these types of things where, and it's really a case where you don't know that you have a problem, because maybe it's not a problem until you open it up to other users. Like, when you open it up to the masses, you now have new problems that exist. Like, if I am the cluster administrator and we're just starting our journey with Kubernetes, and only me and 2 other people on our team can create resources, that may be fine because you have specialized knowledge, you know what to do and not do. But you're going to open that up at some point to common developers and maybe other people, and they don't have the knowledge and skills and practices that you do. And so you need to be able to do things to prevent them from doing things inadvertently that they may not just know. Like, I didn't know that you shouldn't run pods as privileged. I just got this from, like, a Reddit thread, and it works. And it works on my laptop. I should be able to do, like, things like this. You have to start from the beginning, and you have to set yourself up for success and not wait until bad things happen and realize only then, oh man, we really need some policy now.
But I can see that it's possible for bad things to happen because of policies that were maybe set so strictly that someone can't do their job, or
That's absolutely the case, and there's a measured response with all things that has to occur. You have to take a measured response with, what is it that we're trying to solve, or what reasonable protections can we put into place, balancing the needs of security and operations and everything else with productivity. You don't want to stop people from developing and doing their jobs. But sometimes that means that you need to tactically stop them when they're doing things that they shouldn't be doing to begin with. And that is like training people how to behave. And one of the ways that you do that is by introducing policy earlier on, and not, developers can do anything on their laptop. They can do anything in pre-prod and QA and test. And then when you go to production, bam, now we have an outage because we can't deploy. Like, that's what you should not do with policy. You need to train them how to do it from the beginning. And you do that by implementing policy at every step of the way.
And then that leads me to a question. So when you're training people to do it the right way, if I try to do something that is against policy and that policy fails, will I get a message that teaches me about why it failed and how I should change my behavior?
Absolutely. So Kyverno, in its first rule type, you're typically talking about validation, again, the most common case. But in the case of validation, Kyverno has 2 capabilities. Oh, and I realized that we should talk about policy reports, Whitney, because that's a really important aspect as well. But And for a validate rule, you can do an enforce action, which is exactly that. If something gets blocked, then you can even show them a custom message. So you can say, your pod shall not pass. You better go talk to Whitney, and she's the one that's going to let you do that. And here's her phone number. So that can be returned in an enforce message, and the message is fully customizable. So you can put a runbook number, a URL, a person's email address, a team name, whatever that you want. So they'll absolutely get whatever message that you want. Or you can do what's called audit, and in an audit mode, even if it's bad, it'll pass, it'll let it be created, but it'll create a policy report. And that may be a good segue to talking about policy reports.
Are we done with how to scope a policy?
There's more that we could get into, but I don't want to dive down into a rat hole when we could talk about a couple other high level things like policy reports and also the Kyverno CLI, which would be good to talk about those two other components. So
the one thing I want to still get on the board, we had a really great question earlier from Alsaf about an extensive library of ready-to-use policies. I wanted to capture that too.
Okay.
In addition to those other things. So we got this.
I think you're going to have to upgrade to a larger board, Whitney. And get a ladder.
Just, an elaborate system of pulleys and have a harness and excellent. Okay, so we're going to talk about a log. What was it?
Let's cover briefly policy reports.
Okay, policy reports. That's it.
So a policy report is another custom resource inside of Kyverno, the purpose of which is to create an in-cluster accessible running log of the results of policy successes and failures. And the reason why I call it an in-cluster log is because a policy report is a custom resource. It's naturally, therefore, available in the cluster. And this is different from almost every other policy tool where they lock up the results of a policy in other formats. But in Kyverno, we use policy report, which is an upstream and open standard that's developed by the Kubernetes policy working group. And there's actually a proposal, by the way, to make that an official resource type in Kubernetes.
Oh, cool.
And a policy report is really just a running audit log of the results of your Kyverno policies that have applied. And so I mentioned when a policy at a validation rule is in audit mode, if you create something that applies to that rule and it fails, as in it does a bad thing that it shouldn't do, you will actually see that result show up in a policy report. And the value of this is it's separate from the policy itself, which means that you can entitle a separate group of people to just read and access policy reports who do not need the ability to read or manipulate policies. So you decouple the policy from the results of the policy.
Fascinating. So it might be someone's job to see, okay, this policy is failing over and over and over again right here. Like clearly there's a desire for this particular capability in our system.
Or if you're a developer or something and you have only access to your namespace, you don't have access to all of the cluster policies, but you want to see if your resources that you're deploying are passing or failing policies that are in the cluster. You can have access to look at the policy reports that are in your namespace, and you don't have access to look at any of the policies that are deployed. So this decoupling is really actually very important for being able to get other stakeholders involved to understand the results of policies. And Kyverno is the only policy engine that has this capability to date.
So it's good because, like, if a developer could see the results of their policy without seeing a larger scoped version.
Right.
So it controls the scope of who can see what what policy results?
Well, you get to control the scope of who sees them, because since
Uh-huh.
it's just a regular Kubernetes resource, that means you can
Uh-huh.
use regular Kubernetes RBAC to determine who can see policy reports.
Mm-hmm.
And that also means that other tools out there, and Kyverno has an open source tool called Policy Reporter, which you can use to scrape and display and send those policy reports to a variety of locations and in a variety of formats. So it enables those two things. The decoupling has the benefit that you can be picky and choosy about who gets to see the results of policies. And you can also use your own tools to scrape and send those policy reports or do what have you with them.
Mm-hmm. Cool. What's can you like it's not quite sinking in for me. Can you maybe tell me an example of how this would be used?
Sure. So let's say, Whitney, that you had a namespace called foo. Or let's
I
say I
like
like to
I
use pickles because I like pickles.
okay, I
You
like
had a
pickles
pickles
too.
namespace, right? And
Uh-huh.
you are chief developer extraordinaire of pickles. I don't know, maybe
Uh-huh.
you work for Clausen or some company that makes pickles, and so this is
Uh,
like the proto namespace or something. But you don't have
uh-huh.
access to any other namespace. You only have
Uh-huh.
access to your namespace, and you don't know anything about Kyverno. You don't
Mm-hmm.
care. Developers don't care about policy. They care about
Mm-hmm.
deploying their code. And the company who employs you as chief pickles officer wants you to
Mm-hmm.
just deploy code.
Uh-huh.
You don't want to get involved in policy. You don't know anything about it, but you just have access to deploy into that namespace. And let's say that
Uh-huh.
some policies are in audit mode, which means that everything is going to be allowed no matter what, regardless of whether it's good
Oh,
or bad. But
okay.
you're developing in pickles because you need to be able to ultimately promote to production. You
Uh-huh.
can, I, as the administrator of the cluster and
Uh-huh.
the Sultan of Kyverno, can entitle you to see
Uh-huh.
your policy reports in your namespace. And
Okay.
so I can bind that role, and you can see all of the policy reports, regardless of the policies that
Uh-huh.
when you deploy are generated in your namespace. So some of
Excellent.
those resources are going to pass, and some of them are
Mm-hmm.
going to fail. You
Mm-hmm.
don't need to look at a policy to get an understanding of how am I doing, good or bad. You
Mm-hmm.
just see, you do a kube control git policy report dash in pickles, or you
Mm-hmm.
probably have a context set where you don't even need to do that part. And then you get
Yeah.
all your policy reports. And it's just
Uh-huh.
another standard custom resource. So when you're about to roll out Pickles 2.0, before you do
Uh-huh.
that, you can go and look at your policy reports and say, all right, well, Pickles 1.0 actually failed these three policies.
Uh-huh.
So I know that I need to change my resource because this isn't going to be allowed in production. So I better,
Mm-hmm.
in Pickles 2.0, I better go and make that change. Oh, and then by
Mm-hmm.
the way, in the policy report, the message field will tell you exactly what you need to change.
Mm-hmm.
So now you can take this information. You don't have to call me or send me an email or open a help
Mm-hmm.
desk ticket. You've seen
Mm-hmm.
your own policy reports. You can go and make the changes on your side so that when you deploy Pickles 2.0, everything is all green. You don't have any
Mm-hmm.
violations. Everything shows up as pass.
That was a beautiful example, and now that helped a lot. And something it makes me think about is we talk about automation kind of in terms of like, oh, this system can see this event and take this action. But I like automation in terms of autonomy, like giving humans who are interacting with the tool and the system autonomy to do what they think is right or what does follow company best practices without having to have another human make it their job and their business to tell them.
Yep, absolutely. That's a key story that we try and keep in mind when we're doing any of this stuff. And it's not
Mm-hmm.
just, and it starts with, again, making policy easy to write. If you make it
Mm-hmm.
obtuse, and that's a common theme in security, if you make security difficult, people don't do security.
Yeah.
They don't want to do that. You want to
It's so
make
true.
things easy. And one of the ways in making it easy is, again, letting people reuse the skills that they already have. use the tools that you've already invested in. We're not ideological. If you want to use your tools, you should be able to do that and bring them and use them. That helps tremendously.
Mm-hmm. All right. So I think the missing piece from your story was this idea of an audit mode that helped it click for me.
Yep. So that's the policy report story.
Yeah. Cool. All right. What else are we going to do with this little bit of space?
Well, you can, if you have enough space, you can write in the CLI.
Okay.
So this is a command line interface that Kyverno has that allows you to apply policies in your pipelines. So if you have a CI pipeline, and you probably do, or if you don't now, then you probably will, you need to be able to know before you land one of those resources, which is going down through your pipeline and ultimately landing in your cluster, you want to know earlier on in the process, should that thing be allowed, or is that going to get blocked if we just let it be allowed? The Kyverno CLI is a CLI that you can use to easily plumb up into your pipeline of any type to basically know, is this policy when compared against, is this resource when compared against this policy passing or failing? And typically, if it's failing, you would fail the request so that it doesn't make its way into the cluster. That's in a nutshell what the CLI is designed to do.
Why is it good? You're going to know at some point, right? But it's good to do it in the CLI because that's when you're actively doing it and getting the feedback.
Right. So you've probably heard of the whole shift left kind of paradigm and movement.
Yeah.
Well, this is a perfect example of shifting left. You want to shift your policies left, and maybe your policies, as we talked about with the use cases, maybe they're security, they probably are. Maybe they're governance. You want to shift all of that stuff left and know that the resources, if they're not good, you know that as soon as possible, and you don't wait until the last moment only to block them. Or maybe you don't block them, maybe you allow them in a policy report, you see them in a policy report. You want to know about that earlier on in the process so that you can take action. And that's exactly what the Kyverno CLI allows you to do. And it allows you to pick up the policies that you've already written, doesn't require any new type of thing, and just apply your resources to it and see, how am I doing? Is this going to pass if it lands in a cluster, or is it not? If it's not going to pass, don't let me merge the code because it's not going to be allowed.
Excellent. Is that the end of the Kyverno CLI?
I think that's probably the end of it. Yeah, there's some more specifics, but with the sliver of space remaining, because I can barely see your shining face anymore, we probably want to talk about something else.
Okay.
And I think you mentioned the policy library that you wanted to, did you want to dedicate the last little sliver of space there for that?
I am interested in the policy library, but also, you know, it's your project and maybe there might be something important that I don't know about.
There are all sorts of things that we could talk about, like what you could do with a policy. But honestly, the policy library is a really big enabler for folks. And it's one of the driving factors that people like using Kyverno, is that we spend so much time writing and making policies available for your use cases. So for example, if you like using Gatekeeper, we have a full translation of all of the Gatekeeper policies to Kyverno. At least as of a couple months ago, it was a one-to-one mapping. All of the analogous policies are there. If you're using pod security policy, we have all of the pod security policies that are written as Kyverno policies. If you want to use multiple technologies, because again, we're not, we don't want to force anybody to use anything. We just want to provide options. If you want to use pod security admission, which is the built-in admission controller for just pods in Kubernetes, we have policies that allow you to work with pod security admission so you get the best of both worlds. The policy library has like 280 some policies in it right now.
Will you define the library generally? It's a public facing, is it a GitHub repo? What is it?
Kyverno.io/policies.
Okay. So it has 280?
280 something ish. I think it's 283. That number grows all the time. Something like that. Policies. These are all available for you to go and download and try out. And these cover more than just your standard Kubernetes resources like pods and deployments and all of that. A lot of them are for custom resources. So no matter what type, well, it does matter because there are some that are there for that aren't represented for some tools, but there are a lot of tools that are represented there. And if you are looking for a policy for a specific tool, or maybe you've written one, we accept PRs and you can submit it and we'll work with you to refine it and we will make it available to other people in the community.
Custom policies for custom resources.
Right.
You said so much and there's only limited space. So do you want to put the gatekeeper thing in?
Oh, yeah, there's so many policies for all sorts of things that are out there. It's like, well, how do you represent Walmart in 2 sentences?
Well, it's kind of impressive because like Kyverno or any tool, when you just say policy, you're like, okay, like I think of resource validation, I think of yes, no answers. In doing this show, I'm like, okay, Kyverno is not just concerned about Kyverno, it's concerned about like every single other custom resource that Kubernetes that's made.
If you want it to, it's entirely up to how you want to design it. If you only want it to look at pods, then it's only going to look at pods, and it's only going to ask pods get sent to it from the API server. If you want to create pizza as a service and you have a custom resource that you've written called pizza, all you have to do is tell Kyverno, hey, I want to write some policy for pizza, and it'll give it to you.
That's so we have probably room for one more if you want to think of it. I'm gonna make some silly stuff. I am now Chief Pickle Officer.
All right. Now you're tempting me because I have an unopened jar of pickles that's in the fridge. So
I need to make it lower.
Maybe go and grab now. Yeah.
Oh, are you challenging my authority, or are you just sucking up to me? You're just trying to.
No, I'm applying for a job. I want to be your your deputy.
Well, and so I'm Chief Pickle Officer. Yes. And then we got room for you.
I'm just the assistant pickle washer.
Yeah, you're Cheeto Monster. I liked that. Okay, and then let's make it point at you.
Tell you what, I have to make a note. I need new business cards now. This is a subtitle we're having.
Cheeto Monster. Whitney Lee, Chief Pickle Officer. All right.
Perfect. There's not much space left for anything else. That's about all there's space for.
Nothing more about Kyverno.
Yeah.
Did you want to say there is room to say one more thing about the policy library? Converts OPA policies to Kyverno one-to-one.
You could say that we have the gatekeeper policies translated, the pod security policies that are translated, EKS best practices that are translated, Istio best practices that have been translated, or really, I guess translation isn't the best way to describe it, but provided. There's just so many things that are there that there's something for everybody. And one of the things that we continue to hear is that it's so extensive. One of two things: either one, people don't have to write any policies whatsoever, or two, if they do, all they have to do is start with one and then customize it, modify it slightly. And in most cases, that's all they need to do to get off to the races.
I kind of love when tools have a library of examples, because if you're just getting started with something like this, it's so helpful to see what has worked for other members of the community and other organizations.
Yep.
It's as a tool for learning and just to give you confidence that you're on the right track and using it in a way that's going to be effective for you.
Absolutely. And most of those policies come from real world practical use cases that we heard in the community. Like, hey, I'm trying to solve this problem. Here's why this is a problem. And then we've written a policy so that not only they can benefit from it, but other people can benefit. So there are no hello world policies. Like, and as much as, I might like to think of myself as Cheeto Monster, there are no Cheeto Monster policies that are out there. Like, they're policies that are actually solving real world valuable business use cases and everything else in between. And there's no filler. So that's the good thing about it, is they're actually productive things that you can pick up and use to accelerate your journey into cloud native and maybe into production right now in 60, 90 seconds or sometimes less.
Super cool. Well, if you feel like you've said all that you want to say, given the space on the board at least, I'm going to recap everything you've taught me so far to make sure I have a clear understanding of what you said.
All right, go for it.
You feel ready for that? Okay. So we started with a very important question. What is a policy? So a policy is a contract that sets expectations for actions that can or cannot be performed in a system. So these are, despite what you just said, we talked about the big organization specific, although we talked about the library, like it has some like success stories with policies that you can just adapt immediately for your organization. But you might be organization specific in that you're talking about your own namespaces and your own company best practices and your own policies. Policy is good for not just security. What I didn't know this, but you taught me that people have policy and security very much linked in their minds, but you want to kind of undo that myth, it sounds like, where of course it's good for security, like ensuring pods don't run in privilege mode, for example, or preventing that crypto miner from running in your cluster and costing you $30,000 a month until you catch it. But it's also good for governance, so to help you like label all your ingresses a certain way, or automation. So that might be like when a new namespace is created, add a config map in that namespace. Or we used automation, we talked about it in the context of multi-tenancy also. And also policy is good for cost optimization or preventing good people from making mistakes that cost a lot of money. So, for example, there should not be any services of type load balancer in a given namespace, or maybe even like a mutating policy that limits the amount of compute that you're allowed to run in a certain pod or something. So, so that's policy generally, but what is Kyverno specifically? So Kyverno is a policy engine that's built specifically for Kubernetes. So why does that matter? Why is it important maybe to choose one? If you're a Kubernetes shop, why would you want to choose one that's meant for Kubernetes? And so with it being based on Kubernetes, it has some advantages. For one thing, the people using Kyverno don't need to learn a new language. And you talked about your own personal experience and how frustrating it was to have to learn a new language for every different policy tool that you touched. So with Kyverno, everything's written in YAML, and if you're working with Kubernetes, you should be very familiar with YAML and reading YAML and working with YAML. It also, Kyverno, based in Kubernetes, therefore it integrates with Kubernetes tools that you already use. So later when we talk about the main capabilities of Kyverno, like we talk about them in the context of Kubernetes resources, but also in the context of custom resources, that are meant to run in Kubernetes. So other examples we talked about was Helm, or using Kyverno with GitOps, or Kyverno with Kustomize. And then kind of related to the YAML, we have universal reasonability. So since the policy is not written in a specific language, therefore if it's written in YAML and people are used to working with YAML, then they can look at a policy and they can reason about what that policy does without any special training. Art's here and says, great session. Thanks, Art. I'm so glad to have you. Thanks
Art.
for coming. And so those are some reasons why having a Kubernetes specific policy tool is important. And then in order for us to get into the main capabilities of Kyverno, first we wanted to level set and talk about admission controllers in Kubernetes generally. So when you want to make a resource in Kubernetes, it's going to go through an admission controller. So a admission controller is software that has a contract with the Kube API server in the form of a webhook, which is capable of validation, mutation, or other actions in the cluster. So in a more linear way, if you say to the Kube API server, hey, I want to make a pod, the Kube API server now knows of this webhook and can go ask like, hey, is it okay to make a pod before it gives the okay before it writes that request to etcd and goes that sort of thing. So an example that we gave is to validate a pod. So Kyverno actually creates an admission controller webhook. So then upon pod creation, the Kube API server sees that webhook and sends the pod creation request to the admission controller. And then the admission controller says, yes, you're allowed to make the pod, or no, you're not allowed to make the pod. And that's an example of validation. There's also other things that could happen. So all of that happens automatically. You as a user don't have to worry about creating that admission controller webhook. All you do as a user is you install the policy, and then Kyverno does the rest. So when we talk about how it works, it's important to note that these are easy to use, but we just want to understand a little bit of what's happening under the covers, as you say. I like to say under the hood. So now let's finally get into the main capabilities of Kyverno. Actually, let's put a pause in it. And do you have anything you'd like to say or elaborate based on what I've recapped so far?
I think you're doing a great job. I'm
Okay.
actually learning some stuff now. Go ahead.
Amazing. So now we actually had some great activity in the chat too. I still can't fathom how you drew all of that while maintaining a conversation.
I can't
That's very
either,
kind.
Brittany. Honestly, it's a really amazing ability that you have. It's quite remarkable. I could not, if I did this, it would end up being like balloon giraffes. You know, it wouldn't even be comprehensible. I would probably end up going to jail, honestly.
Like, we didn't even know we had a law against this, but we just made one based on this.
Really.
We have hello. Thank you so much for joining. Joined late, but definitely the most important stream I've been waiting for. Thank you so much.
Thanks for joining.
Yeah. And Art says to you, by the way, Chip, I'm still pointing people to Clarity Hugo.
Thanks, Art. Yeah, that for those that may not be aware, I wrote a theme for Hugo, which is a static website builder based on VMware's Clarity standard, and it's been hugely popular and continues to be. So, thanks, Art, and thanks for those who use it. I use it on my own blog. It's been a fun journey.
Good times. Okay, let's get back to the recap business. So we talked about the main capabilities of Kyverno. We have 1, 2, 3, 4, 5, and A, because this one's kind of not a capability. It's halfway in. So we talked about number 1 is validation. So first of all, what are we even validating here when we're talking about validating mutation generation? And we're validating a resource. And when we say resource, we mean like a vanilla Kubernetes resource, but we're also talking about custom resources. So all those add-on tools on top of Kubernetes might create their own Kubernetes related resources, and we can use Kyverno with those resources too. So number 1 in the main capabilities of Kyverno, probably the most popular, the one I knew about before this stream, is resource validation. So basically, is it allowed? I want to make a pod. Am I allowed to make a pod? And then it gets a yes or no response. Yes, Whitney is allowed to make a pod. And if it's a no, it can have a custom message. And in that way, it could teach the people creating Kubernetes resources, often developers, what's right and what's wrong. So it's like, Whitney, no, you're not allowed to make that pod because it uses too much compute. Or because you cannot make that deployment because there are too many replicas. Then I know, okay, that's too many replicas. From now on, I'll only try to make less replicas. That's so boring. But like the point is, I as a user can learn best practices by interacting with the policy. So first, that was resource validation. Excuse me. Next up is resource mutation. So should the resource be changed, and if so, how? So this is good when you want to add information that is only known at runtime. And then I've also heard like an example of it. This is not a real example of what's known at runtime, but if I try to create a pod that does not have a compute limit, but our company policy says every pod that's created needs to have a limit on compute, that could be, the pod could be mutated to have that limit, as opposed to it being validated and rejected and sent it back to me.
Absolutely.
The third up is resource generation. So Kyverno can create new Kubernetes resources altogether. So for example, if a new namespace is created, then clone a specific secret into that namespace. So that's where we talked about enabling multi-tenancy and how it relates to that automation story about something that policy is good for that you might not know about. The fourth main capability of Kyverno is software supply chain. So Kyverno has a rule type called verify images. So it can verify container image signatures, and it can verify container image attestations. So it supports both SigStore and Notary for that. So in that way, you can be confident that the software you're running is the software you think that you're running. So, so you understand the origin of your software. And so that secures the images. And then number 5, we have resource cleanup. So you can clean up any resource. So the example we gave is maybe we want to kill any pods that are older than a certain age. And that's where I would say the Kubernetes control loop comes in, because it's not just looking at the resource when it's being created, but once it's created, it's watching that resource. And if it hits a certain threshold that you've defined, it can take an action. And then the last thing we talked about that isn't technically a main capability of Kyverno, but it is important, is policy exemptions. So you can exempt any resource from any policy manually by creating a policy exception. And we talked about that in the context of like a break glass scenario, like maybe an emergency is happening and you need to circumnavigate these policies that you set up. Mm-hmm. But I imagine there are other reasons you would want to do that too. So that's the main capabilities of Kyverno. So then we said a policy. Now we're talking about like the nitty gritty of doing the work of defining a policy with the Kubernetes, with the Kyverno interface. So a policy is a collection of rules, and then each of these capabilities that we talked about is a rule type. So in Kyverno, there are 2 custom resources, a policy and a cluster policy. And they're a very similar resource, except that a cluster policy is cluster scoped and a regular policy is namespace scoped. So when you want to scope a policy, in your YAML, every rule that you create has a match block. So the match block, you can define what resources to match on, what resource kinds to match on. So if it's a match block of pod, I would say, then when you go to create a pod, that's when this particular policy will come into play. And then there's a bajillion other things. That was the very technical term that you can also match on in addition to the resource kind. And some examples would be labels or namespace or username or group or operation or roles. But that's just the top of the. That's just a little sampling. Mm-hmm. There's a lot of flexibility there. You can also define what you want to exclude. There's an exclude block that says, well, what you don't want to match on. So I want to match on every single pod except for pods created by Whitney. She doesn't have to have any rules. She's the chief pickle officer, and we know she gets to do special things. Yes. So you can create exceptions in that way, or at least like more granular control and how to scope a policy. So then we talked about a policy report. So policy report is another Kyverno custom resource, and it's an in-cluster log of policy successes and failures. So it decouples the policy itself from the results of the policy. So you can use RBAC to determine who could see reports, or you could see which parts of reports. You can use your own tools maybe to scrape and customize and send a policy report. You said maybe a developer is developing in a environment that is in audit mode only. So there is policy watching everything that comes through, but it's going to let everything through, even though maybe in production it would reject some things. So the developer has a lot of freedom to make mistakes, but then the developer can also see a policy report that shows, okay, these actions you took, once your application goes to production, these particular actions aren't going to be allowed. So you need to reconsider your strategy here to make sure to address that once your actual application goes into production. Then we talked about the Kyverno CLI, which allows you to use Kyverno in your CI/CD pipeline. So you can see if a resource is passing or failing before you're actually trying to apply it to a cluster. You could use the CLI to see it sooner rather than later so that you can know what's passing and failing earlier in the process. And then finally, we talked about the Kyverno policy library. There are over 280 policies that are already written and available to the public. Many of these are authored by the community. I love pre-made stuff as a starting point because it's really, really helpful, I think, to see what has been successful for other organizations. So there are many authored by the community. There are policies for custom resources in there. One example we had was translated OPA gatekeeper policies, but you talked about translated pod spec policies, like maybe Amazon specific policies. Like there are a lot of things. And if you've written a really cool policy that you want to contribute to this policy library, you totally should. And I think that's it. Cheeto Monster, how'd I do?
You did fantastic, Whitney. I tell you what a great summarization of this.
Wonderful. I did fantastic because you taught in a fantastic way. It's a team effort for sure.
Well, thank you. I'm glad that Cheeto Monster can bring that to the table.
Well, as Chief Pickle Officer, I didn't tell you this, but the way we like to end episodes around here is by dancing a little bit. I'm going to replay our intro music and we're going to dance and say our goodbyes. How does that sound?
Let's do it.
All right, let's do it. Goodbye, everyone. Thank you so, so much, as always, for your time and attention. It's such an honor for you to share it with us. And thanks, everyone, who watches the recording.
Thank you, everybody.
And goodbye. Yeah, bring it, Chip. Yeah.